Hello students, now the last part of the semiconductors regarding the logic gates. So first of all I have a brief overview of the gate. So the first gate that we say is the inverter is the NOT gate. This is the symbol that we make and the Boolean expression is XA bar, and you are very familiar with the truth table. Similarly the AND gate symbol and the Boolean expression is AB or A dot B, what you write, and this is 1 only when both inputs are 1. Similarly if you have 3 input AND gate, it would be 1 and all 3 are 1. OR gate, you have when one of them is 1, the answer is will be 1. The expression is Boolean expression is X is A plus B. The NAND gate, that is the, you can say, AND gate, and we put an inverter in front of the output of the AND gate, so it is the reverse of the NAND gate. Its output is X is AB is for AND gate, its bar that will give you NAND gate. Similarly the NOR one, that is the inverter of NOR. That all you know. These two gates you can also remember, though they are exactly not in syllabus, but they also works. XOR means exclusively OR. It will be 1 only when one of them is 1. If both are 1, it will still be 0. And similarly the inverter of XOR would be XNOR. You can have this truth table. Now out of the gates, NAND and NOR are called the universal gates, because simply by only using NAND or only using NOR combination you can realize every Boolean function. So for example, NOR or a NAND, both if the two inputs are, it's basically 1. If the one input is fed in both the inputs, it will basically act as a NOT gate inverter. So just remember these two will act as inverter, and here because it is inverter, put the NAND output into this will become a AND, put a NOR output into this, it will become a NOR. And similarly this is what we have: 3 NAND gates realizing OR function and 3 AND gates realizing OR 3 NOR gates realizing the AND function. You can check it yourself by 0001 doing that the truth table exactly matches. Now these two theorems typically not needed, but if you remember that might help in some questions. De Morgan theorem, it simply says NAND gate is equivalent to bubbled OR. Bubbled OR means it is, you can say, OR is A plus B. Bubbled OR means A complement plus B complement, or A bar plus B bar would be AB whole bar. That means if you put A inverter, B inverter and feed it to an OR gate, the output you can directly say of the NAND gate. Similarly for a AND gate, if you get the bubbled AND, it will be the NOR gate. Similarly you can have this. So these two theorems are very important if you do by the De Morgan's theorem. If you don't do, if you prefer only the logic gates, that not needed. Now this is an important thing, circuit realization of logic gates. There have been questions asked in JEE Main, not in NEET till now, but in JEE Main questions have been asked. Just take a screenshot of this realization. I'll try to explain some of them in the questions I have taken, but this is the circuits that you can remember and you can decode yourself. Take these two screenshots, first this one and then this one. Now, so based on how we calculated that how to use the NAND gates to realize all the functions or the NOR gates to realize all the functions, you can simply check yourself with first this question, take a screenshot, second this question, you can take a screenshot of this also. Now the question I will be taking first for you is this one. For the given logic diagram, output will be 1, then inputs are. So when the output will be 1, first of all this is an AND gate. AND gate means both should be 1. So both should be 1. For this to be 1, C has to be 0 for sure. So I can reject these two options. Now C0, 2 options are left. Now for 1, if A and B both are 0, this cannot be 1, so it is not possible. A0, B1, yes it will be 1 and it will be 1. So you can go for option B in this particular case just by the logic. Do the same analogy here. This is again a test yourself. This is AIPMT mains 12 question. Take a screenshot, try yourself. Next, this is a very basic sort of question that you also get. If ABCD are inputs to a gate and X is its output, then as per the following time graph the gate is. So what we have, ABCD are the inputs, it is 4 inputs. You see it is always 1, it is 0 only when all are 0. Otherwise here you have 1 0 0 0, here you have 0 1 0 0, here you have 1 1 0 0. So it is basically OR gate. You can make it out. It is if any one of the 1 is 1, it is 1. So this is OR gate, directly you can go. Now which of the following circuits correctly represents the following truth table? Now look at this truth table. It says output is 1 when A is 1 and B is 0. So when A is 1 and B is 0, it is 1, that is it is being given here. So how to check here? So how to check this? So let's say first check the case of this 1. Let me try it here. Put it 1 and 0. So 1 means 0 here, 1 and 0 here means 0, so 0 and 0 will definitely give you 0, and that will give you 1. So that is satisfying. But let me check one more. Let's say 1 and 1. So if I do that 1 and 1, it would be still be 1, so it will become 1, so output would be 0. And similarly, if I have 0 and 1, if I have 0 and 1, it will become 1, so it will be, for any 0 will be there. So A of first option satisfies all the condition, so we are lucky, we don't have to check for other one. So this is JEE Main online 13 question. Now this is an interesting one. This is a multi combination. You have to find the truth table. Now one thing is De Morgan theorem, but I don't generally recommend at your level. What we will do, I'll try all the cases. First of all, take it 0 0. So this is 0, this is 0, OR will give 0, so NOR will give 1. So this is 1 1, this is 0 0. So 1 and 0, OR will give 1, so NOR will give 0 0, 0 0, OR will give 0, so NOR will give 1. So 0 0 will give you 1, 0 0 1, you are left with these two choices. Now just check where they differ. They differ in 0 to 1. So let now 0 and 1. 0 and 1, so what we have, this will become 1. So OR will give 1, so NOR will give 0, so this is 0, this is 0, this one is now 1. So 1 and 0 will give 1, so it would be 0 0 0, here will give us 1. Now 1 and 0, NOR will give 1, so NOR will give 0, so 0 1 will give us 0, so we are left with option 4. That is the answer that we can go for in this case. This JEE Main online 13 again. Now this is the question I am talking about for the JEE Main students. Consider two NPN transistors as shown in figure. If 0 corresponds to false, 5 volts corresponds to true, then the output at C corresponds to. Just look at this figure. Just see, there are two paths for this current to flow through this resistor. One is via this one, this is acting as a switch, or via switch 2. And you can make it out, switch 1 and switch 2 are independent, that is they are in parallel. So whenever the connection is in parallel, it will either be OR or NOR, so I can reject AND and NAND. Now whether it is OR or NOR, just check. Now C will be 5 volt or 1, C will be 1, or you can say plus 5 volts if the drop across R is 0. If the drop across R is 0, that means no current flows. No current flow means, that means both the switches must be off. Both the switches must be off, that means both the input should be 0. So if both the input is 0, then we will have output as 1. If any of the input is 1, if any of the switch is conducting, the current will flow, and if current flows, we will say this or this or this will be at the same potential, so C will be grounded. So we will say C will only have plus 5 volts or output high if both the inputs are 0. So for both 0, output is 1, otherwise it is 0. It would be the inverse of OR, you can say it is A nor B. Go for option 4 in this particular case. Next one. Now this is very interesting. Given A and B are input terminals, logic 1 when it is greater than 5, logic 0 for less than 1. Which logic gate operation the following circuit does represents? Now you get a feel that V output is always 6, but just be realistic, just leave that point and just think. For this 6 volt, current can flow via this path, and via this path. You have 50 and 50 here, and here you have 10 kilo ohms. Just think of a road, you can travel by 3 roads. One has a 50 rupee toll, the other one also have a 50 rupee toll, the third one has a 10,000 rupee toll. So in the normal circumstances, you will not prefer, this is not preferred road. So this is never a preferred road. So this is never a preferred road, so it will remain 0. So if the current doesn't flow through this, that means if the two roads are open, no traffic will come through this, and if it is 0, this output will be 0. So output will be 0 if any of the two roads is open. So for these two roads to be open, one of the diode has to be forward biased. That means either A or B is 0. So if either one of them is 0, you will get the output as 0. So if any one is 0, you will get the output 0, and you will get output 1 only when the current flows through this path, and this will happen when both are reverse biased, that is both is 1. So when both are 1, you will get 1, otherwise you will always get 0. That means it is an AND gate for sure. So just try to analyze this. The values of the resistors are very important here. Next, truth table for the following digital circuit. Now you have to solve yourself. This is JEE Main online 2018. Now try that 0110 thing, whatever you do, and try to find out the answer. So this was a very short video to help you. So thanks for watching.